Good morning, pre-calc students. Sorry, you might hear an angry baby in the background. I'm home nursing him back to health, so to speak. Okay, your first objective today is to finish the do now. So at this point, if you're filling in for me, you can pause the video and give the students 5 minutes to attack problem number 1 and problem number 2, each systems of linear equations. Go. Now I'm about to go over the answers. So if you haven't unpaused the video yet, please do so. Remember that these are two linear equations, meaning they're either going to be parallel, they're going to be the same exact line, or they're going to intersect exactly once. And so we want to know at what point do the lines intersect. Well, they're both in y equals form. So when that happens, we can actually set the two other expressions equal to each other. And now what we have here is a simple equation with x's on both sides that we can now solve to find those x values. So I'll just try to get rid of this 4x over here. I could have chosen the other one, and you get the same answer in the end. And I get negative 10x, and I subtract 23 from both sides. That gives us to what? Negative 40 equals negative 10x. Well, divide that by negative 10, and you get 4 as your answer for your x value. Now, that's not going to be everything, because you know we want a point, which is an x and a y value. That's a coordinate pair. And so with that being said, we're going to plug that 4 into either equation to get the y value. So notice how I'm actually taking this first equation, and the only thing I'm changing is the x based on what I've already found. Now I get y equals 16 minus 17, which is negative 1. Now I could check my answer by plugging it in here as well, that 4, and I should also get negative 1. So let's just make sure that we write this coordinate point for negative 1. Make sure that you have that. Let's go over problem number 2. Problem number 2 is a little bit different because these are not in slope-intercept form. These are both in standard form. So we need to use the elimination method. And so what that means is we're looking for things that are equal but opposite, same number, opposite signs. And we can actually see, we don't have to do any extra math here. The negative in the 3y and the positive 3y are going to cancel each other out. So all we have left to do is put the rest together. 5 and negative 2 becomes 3. Negative 22 and 16 becomes negative 6. And if we divide by 3, we get negative 2. And so from here, we again just need to find the y value. So we'll do 5 times negative 2 minus 3y equals negative 22. I'm just plugging into this first one. We've got a little bit more work to do to find the y in this case, because now I've got to solve a little bitty equation. So I'm going to add 10 to both sides. That gives me a negative 12. And I'm going to divide by negative 3, and I'm going to get a positive 4. We want the point, right? That is the solution. Solve the following system. And so we got negative 2, 4. So not only do we know that these lines are going to intersect both of them, we know that they're going to intersect only once, and that they must intersect at the points that we have found. Okay, great. Let's move on to the Explore task today. Okay, moving on. There's a blank page, and there's this page. And then you finally get to this page, your mad minute. Sorry. Let's go to our mad minute. All we have to do here is identify the zeros of each of the following polynomials and state the multiplicity of each. You should take 4 minutes for this mad minute. So if you're in my room, set the timer for 4 minutes. Begin. Pause the video so you don't get the answers. Okay, focusing on just the answers for the first 3 and the first 3. Only check them. Make sure that you have all of the roots. These were all in factored form except for number 3, in which you'd had to factor out a GCF and then factor this out based on your C term. With that being said, we get roots in the first one of 3, 1, and 2. Or sorry, 0, 3, and negative 7. And our multiplicity was just found, remember, from the exponent on those roots or factors. Remember that those multiplicities tell us if a function is going to bounce or cross on the x-axis. Make sure that you have these answers. Take a moment to copy them down. Okay, now we're going to do the Explore task. Please follow along with me. This would be times where I'd be asking you for previous information that you knew or know about lines and graphing. Now, on the grid to the right, sketch and label each of the following 4 functions. What we should see here is this first function is a quadratic We know it's a parabola U-shaped facing upwards. And we actually know that it's been shifted down 1 to have a y-intercept of -1. So for this parabola, we're just going to make a U-shape. Here are some points on that parabola. We're going to just slowly sketch that going up, and we're going to label this one f of x on our graph. The next one that we're going to sketch is g of x equals 3. This is the same thing as y equals 3, right? And so this is going to be going straight through where we have a value of y equals 3. 1, 2, 3. That's a horizontal line. Sorry, that should be going right through the 3. I'm a little low there, sorry. And that's going to be g of x. And then, of course, we've got to do the same thing with the next two at -1. And that's h of x. And then finally at -3. That one almost goes through the line. And that's k of x. And so what we have here is really a system of equations. They're not all linear. And in fact, what I want you to start thinking about today and doing on your own today is finding solutions to systems of equations that aren't linear. And so if we really highlight here, what we're going to be asked to do is actually find down below. I don't want to scroll down too far and lose my drawing. The equation and the number of solutions it has. So we're going to start with f of x and g of x. Let's go look at f of x and g of x. And let's see if we can highlight that. So f of x and g of x actually intersect at 2 different points. And so down here, we just want to know the number of solutions. That's going to be 2. And the justification is because our parabola and our linear function, our quadratic and our linear function, intersect twice. They have 2 points in common. And so we want to do that with all of these. We want to do that with f of x and h of x, basically that parabola and all of the linear functions. So with g of x, there's 2 solutions. With h of x, there's actually only 1 solution. It just kind of comes down to the bottom and barely touches the bottom. You can think that parabola, oops, I actually have that in the wrong spot. Remember that parabola was at a y-intercept of -1. There we go. That parabola just dips down to -1. That's the lowest it gets. And this line is constantly at -1. So they only have 1 solution. And k of x is going to have no solutions. And so it has nothing to do with really the fact that they're lines, but where those lines are and how they're running and how they're intersecting. So you can see here, this is actually a little bit different. With linear, with 2 linear, we had 3 options. We had 0 solutions, 1 solution, or infinite solutions. But with a linear and a quadratic, we actually have more options. We have, well, not more options, different options. We have 2 solutions, 1 solution, or 0 solutions. And we can see that there won't be infinite number of solutions because a straight line and a curved line won't ever be really the same. And so in that way, we're going to have some different solutions here, and we can see them graphed over on our right. Make sure this is in your packet. Now we're going to go to our notes, and we're going to take some notes on this. The first question in your notes is right here, example 1. We are going to find a solution to all of these, and we're going to confirm the solution with a sketch of our graph. So we're actually not going to start with our graph. We're actually going to start with how we would solve this algebraically. Well, just like the do now today, we can see that these are both y equals. So when that happens, we can set the rest of the expression equal to themselves. They're both equal to y, so therefore they must be equal to each other. Now I've got a little baby equation here, and where I got x's on both sides. I've got an x on the left and I got an x squared on the right. Well, this is actually a quadratic function, right? Or a quadratic equation. So whenever I have a quadratic, we need it to be equal to 0. So what I'm going to do is I'm going to add 4 to both sides. I'm going to add that with my regular number, and I'm going to subtract x from both sides. And I'm going to subtract that from my x value, and I'm going to rewrite this. So my new equation is going to be, well, 0 equals, that's good, I got 0. The x squared stays the same. The 2x minus x, that's going to be a minus 1x. And this -16 plus 4 is going to be a -12. Now from here, we have a lot of different options for what we could do. but we should always look to factor this. This is what we've been practicing. This was our Mad Minute. And so factoring is a great strategy whenever possible for quadratics. And this -12, we know factors of -4 and 3 will give us 12 and will give us -1. So we're going to break this down into 0 equals x minus 4 and x plus 3. Now we have two solutions here, x equals 4 and x equals -3. But remember that when we're finding the solutions to a system of equations, we actually need both the x and the y coordinate. So after we get these, we're going to plug in. Now you ask yourself a question, which of these would you rather plug into? Would you rather plug into the first one, that linear one, or the second one, that quadratic? Hoping you're choosing that first one, the linear one. So let's plug in over there. And so what I got is y equals x minus 4. What am I plugging in? I got two different things to plug in. We'll do them one at a time. 4 minus 4 is 0. And then I got y equals, well, x minus 4, and that x is going to become -3 this time, which is -7. And so we've got two different things here. We've got a point at 4. When I plug in 4, I get 0. And when I plugged in -3, I got -7. So those are our two solutions. We boxed those in. It told me to find those solutions. There are my solutions. It does say to confirm with a sketch. When we sketch these, the first one, y equals x minus 4, it's a linear equation with a slope of 1 going through the -4. Okay, so I'm going up 1 and over 1, starting with my y-intercept of -4. Remember, y equals mx plus b. Remember, rise over run for your slope. That's really a 1 over 1. And then something like x squared plus 2x minus 16. This is where things get a little bit more difficult. I've got something like a -16 here. That's going to be a y-intercept that's way down below our graph, like way down there. And then I can actually start plotting points based on like maybe where the vertex is. And if I use -b over 2a to find the vertex, that's going to be -1. It's going to be over here. Well, you can just see, okay, it's not going to be perfect. But if I were to kind of just generally sketch that, I can at least see that I'm going to have two solutions here. And I'm not too concerned about the exact, how exact we are with our sketch, as much as just confirming the number of solutions based on where those graphs are going to be. And I kind of know this because if I really focus on that y-intercept for my quadratic way down at that -16, that's going to be so far below that linear function that it's going to have to come up and hit twice. And so that to me is a nice little kind of check to make sure that I should at least have two solutions. I'm going to clear these, make sure that you got these in your notes. And I'm going to send you to problem set A. And this is going to be your work for today. So star the following problems with me. Number 1. Please do number 1. Number 2 is just like our notes problem. Please do number 2. And number 3, this is a good challenge problem. I want you to do number 3 as well. So all of practice set A at the beginning. If you'd like to work on your pacing, I would say 10 minutes for that. 10 minutes for practice set A. Once you get done with practice set A, I'm going to have you skip the problem set B, but watch, I'm skipping ahead, skipping ahead, skipping ahead. You're going to go and find just number 4. This will be kind of like your last little example for you to try. And then lastly, let's go all the way to the exit ticket. And for this exit ticket, I want you to just do problems 1 and problems 2. Sorry that I can't be there today. I hope you find this video helpful. For anybody who is covering, thank you. I appreciate you. And I'll try not to put you in that position again.